Hello everyone, thanks for coming. My name is Tet Oo. Let me present to your attention. As you can see on the screen, our topic today is processing of the titanium alloy by high-speed steam to with combined survey treatment. The possibility of obtaining high-quality finished product from a high RSP resistant alloy is very promising. When using the additive method of growing the product, it turns out not a finished part, but it will be with a survey roundness 10 to 13 micron. Thus, it is necessary to resort to finishing or even semi-finishing cutting. Products obtained by 3D printing usually have a rather complex shape. These are usually single or in extreme case small scale products, so it is advisable to make a special tool from high-speed steel. It is possible to increase the durability of such tool due to complex survey treatment. The paper compares the durability of tool made of high-speed steel and do with complex survey treatment with milling blade made of TIC and 4B alloy obtained by selected electron beam method and using traditional technology. And in the slide, we can see figure A, the workpiece obtained by traditional technology forged which underwent incomplete annealing at a temperature of 680 degrees Celsius for an hour with air cooling in the air. And the hardness of material 275 HP. Figure B, the workpiece obtained at the Arcan A2 selected electron beam method unit was obtained as follows. A layer of powder with a thickness of 50 micron was successfully applied to a stainless steel platform preheated to 750 degrees Celsius. And the speed of the electron beam was 1200 millimeter per second. The hardness of the material 380 HP. In the slide, methodology of the experiment, figure A. Experimental milling plate made of high-speed steel. Figure B. An experimental plate made of medium alloy high-speed steel. M2. After standard heat treatment with choosing as the tool, milling was carried out a particle cantilever machine WF1. Using a dynamometer from Castellar, Switzerland with DynaWire software. Figure C. The milling process was modeled using a special holder and experimental metal cutting plate. The slide shows microalloy of pre-nitrate high-speed steel. Figure A, the outer layer of the blade was enriched with refractory nitrate phase. The depth of the near surface layer in which the modified surface modified structure was obtained up to 10 micron. Figure B, distribution of sand chemical element in the near surface layer. Figure C, deprogrammer. Figure D, the distribution of hardness by depth showed that it increased by a depth 80 micron. We can show figure A and C. In comparison, figure A and C give an idea of how significantly the structure of the titanium alloy affect the components of the cutting force. 1 milli a workpiece obtained by electron beam method. The cutting force absorbed increased by approximately 50%. At the same time, there is a 20% drop in the force of Fy. Figure A and B. One using a tool with a hardened layer by means of complex survey treatment. The cutting force Fz is reduced by half when processing a forged workpiece. Figure C and D. 2.5 times 1 milli an alloy obtained by electron beam method. The value of Fy force decreases slightly in the case. Figure B and D. One processing workpiece obtained by electron beam method. The components of the cutting force are approximately the same. But should be noted that the measurement of the component Fy is shifted toward a smaller angle rotation than cutter 2. Due to the fact that the material obtained by electron beam method is harder, there is a slight increase in the axillary component of the cutting force Fh. The slide shows the result of wear resistance test 1 milli force and electron beam method workpiece. The amount of wear on the rear surface 0.2 millimeter is selected as the wear criterion. It is shown that the use of complex surface treatment made it possible to increase the tool life during milling in the specified mode to 6 times. As a result of complex processing, the characteristics of the contact process change, which reduce the intensity of the heat source near the cutting edge of the tool. The stability of the cutting edge shape increases. The modifying layer continue to perform a productive function even after the damage of the coating, which affect the weight of the tool. Finally, conclusion. Thank you. Thank you for your attention.